Hello friends, we're going to quickly solve an example to illustrate how to use relaxation, and we'll take this example 5.3 and it reads, use the Gauss Seidel method with relaxation equal to 0.9 to obtain the solution of the system of equations. Note the true solution of this problem is x equal to 3 minus 2.5 and 7 for the following equations. 3x1 minus 0.1x2 minus 2x3 equal to 7.85. 0.1x1 plus 7x2 minus 0.3x3 equal to minus 19.3. 0.3x1 minus 0.2x2 plus 10x3 equal to 71.4. Solution. First, solve each equation for its unknown in the diagonal. That means we're going to find the value of x, x1, x2, and x3 for each of the three equations. For x1, this is what we have. For x2, this is what we would have. For x3, this is what we will have. Remember the Gauss Seidel method. x2 and x3 will be substituted as 0 into the first equation to give us a value, and that value will be used to substitute into the new equation x2. But before that, we will apply the relaxation rule. And this is the rule. Relaxation. This is a concept that is designed to enhance convergence. After each value of x is computed, that value of x is modified by a weighted average of the result of the previous and present iterations. And this is the function or formula of how to derive the new value, weighted value, that we're going to apply in our question. Okay, so if we apply that formula, we'll put this value of x1 that has been derived and get a new weighted value using that formula. So this is what we will do. 0.9 times 2.6166667 plus 1 minus 0.9 times 0, and this is the value that we'll have. So this value will be substituted into x2, into the x2 function. Remember, we're not going to substitute this value, but we'll substitute the new weighted value, and then we'll get this value. Same goes for x3. So for x3, we're going to use the new value 2.35003, and the value for x2, which is what? Also minus 2.5. Mind you, for each of the values of x, x1, x2, we're going to apply relaxation. Okay, so we apply relaxation for x1, we apply relaxation for x2, and we apply relaxation for x3. So our first iteration, that's how we get our values. Okay, so for our second relaxation, remember, we'll use, to get our x1, we'll use the previous values of x2 and x2 and x3 that was gotten in our first iteration. So when we get that value, we'll apply relaxation. on the new x1, okay, giving us a value. Now it is this relaxed value that will be applied to find x2 and also x3. Then also remember, we'll also apply relaxation first before we proceed with our iteration. Now the true solution of this problem is x is equal to 3. That means x1 is 3, x2 is minus 2.5, and x3 is 7. This method is converging to the true solution. Additional iteration will drive the problem to its true solution. The relative errors can also be calculated at each iteration to the stopping criterion. It is important to mention here that all the given equations must satisfy the stopping criterion before the computation is terminated. The convergence can check using the criterion. So this is the formula we use to check the error. That's the initial value of x, the old value of x minus the new value of x all over the old value of x. And then we'll have this sign which shows that negative will not be considered, just the magnitude, but the sign negative will not be considered, times 100% should be less than the given criterion. So this is how to apply relaxation while solving your Gauss Seidel iteration. Thank you.